Dr. Nathaut, am I audible to you?
Yeah.
You can hear me?
Yes, I can.
Okay. So for the keynote lecture 9, we are expecting Professor Mamdood Hussain.
Yeah.
From 10 o'clock, right?
10 o'clock, yeah.
Yes. So the time is around 10 o'clock now?
10 o'clock, yes.
Yeah, okay. So let's wait for a few minutes. I think he will join.
Okay.
Sure. Good morning, Professor. Is it Professor Harun? Hello, I think you are muted.
Yeah.
Yes,
Can you hear me now?
Yeah, clearly. Yes.
Okay. All right. Thank you for joining in advance. Yeah, because the keynote speaker a little bit delayed session.
Right.
So yeah, we just concluded that one. So
yeah, the plenary talk, that is.
Yeah, plenary talk. That's why.
Right.
Just okay. So now is it our presenters are ready here?
No, we don't find Professor Mamdood Hussain. He has the keynote lecture 9 from 10 to 10:30. So I think it is 2 minutes past 10. So we are waiting for him.
All right. Thank you for your patience. I will just talk to Professor Firoz.
No problem.
Maybe he can better because he has the idea about his invited speaker.
Yeah, no
so
issue.
he invited
No
all
issue.
of them.
Yeah. Okay.
Just need to talk to him regarding this thing.
Sure. And Dr. Nathaut is also with us. He will be co-chairing.
Oh, thank you, Doctor. So I've just let me check with Professor Firoz what actually, if there is any update.
এই অনতা,
হ্যাঁ বলুন, গুড মর্নিং।
আপনার প্রেজেন্টার কই?
হ্যাঁ উনি নেই দেখছি তো।
এই মানে ইংল্যান্ডে ঘুমাচ্ছে।
আহ, আমি জানি না উনি ওই টাইমটা ক্যালকুলেশনে কোনো গন্ডগোল করে ফেলেছেন কিনা, সেটা বলতে পারবো
Definitely,
না।
কিন্তু কিনোট স্পিকার, হ্যাঁ, কারণ এখানে they need to look at the time,
হ্যাঁ,
because I think in England time is now around 1 o'clock,
ওকে।
1 or 2 o'clock, something like that. But Professor, for example, tomorrow we have Professor Young, and he confirmed that this time is quite okay with him.
ওকে ওকে।
So what we'll do,
হ্যাঁ,
it is very sad, then we will wait for a few more minutes, and then if he can join, that's fine. Otherwise,
okay.
you will continue as normal session.
Okay, fine. So
Normal session when the time after half an hour. I mean,
exactly. So
it is
we'll
already, I
follow
think,
the
7 minutes.
right.
So they
We'll
have
follow
only
the
22
schedule
minutes.
only, right?
Yeah. Because some other people can move from
Correct.
one session to other session. So
Correct.
it is better we'll continue
Correct.
with the scheduled time. Yes.
That should be fine. So that means in that case we'll have a tea break in between.
Yeah, it will break, but at the moment you wait and see still.
Yeah, that's fine.
And of course you can have tea break,
Yeah, in fact, if Professor Hussain is able to join even now, we can hear his lecture. I mean, maybe in a short form.
Yeah, then he has to go with the speed of light.
Yeah, of course. Let's see.
Okay. Because I do not have his
Contact.
His mobile number.
Mobile
So
number.
I can give him a call or something.
Right.
But I see whether I believe that I don't have. Let's have a look.
In this figure, we'll take a look at the total power performance rate in each region. We can see that the Qinghai and the Hebei are the provinces.
Due to some inconvenience, he's probably not able to make it on time. So we'll wait for a while. There is still a few more minutes left. We'll go as per schedule. So we'll start the next paper from 10:30 a.m. Thailand local time. So currently, I think it is about 10:15 or so. Yeah, so another 15 minutes. If Professor Hussain is not able to join, we move on to the next paper. I think I'll just check. It is paper number 117. So Mr. Abdul Aziz from RMIT, Australia, he will be talking about new technologies for sustainable transport in that paper, which will start from 10:30 a.m. onwards. I request all the speakers to kindly stick to their time limit of 15 minutes. So it will be very nice on your behalf if you can spend about 12 to 13 minutes on the presentation and at least leave 1 or 2 minutes, if possible, towards the end for a question or two. If you can spare another 2 minutes from your presentation, it's still better, but it may be difficult. So in that case, at least enough time for 1 or 2 questions is what is requested. Thank you very much. Thank you for your patience. And we'll just wait for a while before we can begin the proceedings.
না, খুঁজে পেলাম না। স্যার মোবাইল ফোন চেষ্টা করছিলাম।
ঠিক আছে ফিরোজ সাহেব, অ্যাকচুয়ালি আমাদের সময়ও এখন কমে এসছে, ফলে আর হয়তো 12-13 মিনিট বাকি, ফলে ধরে নিতে হবে এটা হবে না আর কি, সেটাই ধরে নিতে হবে এখন।
fluid is manufactured method for China.
অনন্ত আমাকে যেতে হবে সেশন 1-এ, কারণ ওখানে ওই বাংলাদেশের এক স্টুডেন্ট মানে অথর সে আনফরচুনেটলি কুড নট অ্যাটেন্ড।
আচ্ছা, ওকে।
ওকে, সো cannot
ঠিক
attend
আছে।
or I could not
হ্যাঁ,
attend.
নো প্রবলেম, নো প্রবলেম।
So এখন আমি ওই ব্যাপারটা প্রেজেন্ট করতে হবে।
একদম, একদম।
হ্যাঁ, করে আমি পরে আপনাদের জয়েন করছি।
শিওর, শিওর, শিওর। থ্যাংক ইউ। Good morning once again to participants of this session number 9. So we are just waiting for the next paper to be presented. I think we have Mr. Abdul Aziz from RMIT presenting the next paper. I can see his name here.
Yes.
Yeah. Thank you very much, Mr. Abdul Aziz. So we'll just wait for another 2 minutes, perhaps. I think it is about 10:28 or so, Thailand local time.
That's right. Yep.
Yeah. So we'll just go by the allocated time. We'll start sharp at 10:30, and you are requested to complete the entire presentation within 10:45. Towards the end, if you can keep 1 or 2 minutes for a question or two, it will be very nice.
Okay, that's right.
Thank you.
So we're
going
to start after 3 minutes. Is that correct?
Yeah. It's going to be another minute, 1 minute actually.
Okay.
One more minute, and then you can share your slides and go ahead with your presentation.
Okay.
Thank you.
Can you see my, I've shared the screen. Did you see it?
It came for a while, but now it is again not visible.
Okay.
So could you share it once more and go to the presentation mode?
Yep.
Yeah, now it is visible, but not yet in the presentation mode.
Okay. Just give me a sec. And
Yeah,
now?
that's nice. That's absolutely fine.
Okay. Can you see me, or I think the light here is not?
Yeah, you are visible. You are visible.
Okay.
Thank
That's
you.
right. Okay. So, yep. I can start now or just 1 minute?
I think you can go ahead.
Okay. So, hello everyone. My name is Abdulaziz Al-Dakhilallah. Today I'm going to present the development of new technology for real-time traffic monitoring with my colleagues Nerjan, Tom, Justin, Weston, and Milan Simic. So before we start, I just want to give you a quick look of the two beautiful cities. So I live in Melbourne doing my PhD. As you can see in left pictures, that's from the campus in RMIT in Melbourne. Also, I'm originally from Saudi Arabia, and this is in the right hand Riyadh city with the train and some quiet traffic over there. So the outline will be the introduction and computer vision investigation, computer vision algorithms, and on the road, RTT traffic management subsystem deployed, safety analysis, real-time monitoring, data on demand, public readiness for the new technology, investigation and autonomous vehicles introduction as ITS subsystems, and then the conclusion. So let's start with the introduction. So the main goal of this project is reported to have the improved transport safety and efficiency. We've been working with the real-time traffic company from industry side and from RMIT as a school of engineering. So development of new computer algorithms like applied or applications of AI, artificial intelligence, Internet of Things, cloud computing, investigation, and raising public awareness, and all of that for the transition to the autonomous transport sector. So computer vision investigation. So as you can realize when you go out, all humans collected a large amount of data, visual data on the road while they are driving or walking, as well the intelligent transportation system and the autonomous vehicle doing the same vision approach, supply the most valuable information. Computer vision algorithm on the road. So deep learning used for computer vision system deployed for the 3D object detection, as you can see in the right hand, that took from the drone as a 3D capture area. It shows the pedestrians, cars, and other objects on the road or close to the road are subject to the DL vision process. Computer vision calibration, the camera lens distortion, as you can see in left hand, the picture that was in the wide angle, but the accuracy of measurements is not quite accurate. So it has to be the picture exaggerated by the camera, so it should be having the same and exact object measurement. So as you can see here in the distance and the video camera as showing of the picture. Also the computer vision calibration, number of pixels and on an image to 1 meter in physical world. So the markers in the physical world are used to calibrate pixels on image to actual pixel distance, and that took by the drone. So we measure the pixel distance based on knowing roadside objects, police, traffic signals. Sometimes markers are spray like painted on the ground at measure distance and then captured in the video camera, as well as in the drone, as you can see. So here the pixels on image, we took it from the GPS coordinates in the physical world. So we used the drone to capture the GPS coordinates at each of the marked points. As seen on the picture, drone like capture the image and angle viewpoint allows to construct the 3D model of the area. So the vehicle, as you can see in the left picture, the vehicle position can be calculated relative to the nominative to track road safety metrics, such as vehicle distance to the center of the road. Calculate motorbike ride path and speed profile are measured with the multi-view geometry techniques. The RTT traffic management subsystem deployed the real-time, which is the well-established traffic engineering company here in Melbourne, has already deployed a solution as a subsystem of the future common ITS, which is the information transport system. A new technology based on computer vision and the artificial intelligence provide opportunities for improvements, traditional traffic surveys, methodologies, optimization of the existing and practical application of new solutions. The safety analysis here, the subject of the road safety has long been major objective for the federal, state and local government here in Victoria, and defined action to reduce a fatal and serious injury crashes in Australian roads. Road safety involves the 3 interlinked factors: the vehicles, human factors, and the road system. These currently provide the basis for road safety analysis and funding to reduce incident and improve road safety. Real-time monitoring. RTT main object is to deploy and test a new real-time traffic management and control system. The aim to provide comprehensive integrated cloud-based system focusing on the requirement of temporary traffic management solutions because of the road war, transport deployment, special events, freight deliveries, and major incidents. RTT has many ITS subsystems in this domain already deployed on Victorian roads. Data on demand. So here, the real-time traffic is deploying concept of data as service to provide integrated data accessibility to a wide range of users. Our solution here, as you can see, the implementation of the latest technology to support a lower cost of big data management, a serverless database architectures, effective resources, and cost management. So, public readiness for the new technology, together, like with the government, traffic authority, industry, general public, one of the major stakeholders in transport sector. Together with the research, the development with the new technology, and integral part of the future of ITS systems like autonomous and electrical vehicles. We are investigating possible roadmaps for the new technology introduction and also asking for the public opinion of the future mobility, which is the transition to the electrical train, or will give less pollution to the world. As we are now speaking about the global warming and all people talking about it, so the autonomous vehicles and electrical car will play important roles to move towards these regions that most of the countries applied. So all the ITS and autonomous vehicles will help to achieve towards zero emission. I'm sorry, zero gas emission. And I'm sorry, we in Melbourne here, the global warming, I think it's called because we have 9 months of cold weather in Melbourne. So transition to autonomous vehicles should play the role in more efficient transport system with better throughput, travel time, and consequently less engine running. There are 6th level of autonomous, and we have all levels currently on the road depending on the countries. And just a brief summary of these 6 levels, which is defined by Society of Engineers, International Engineers, which is defined it from the no autonomy at all, which is level 0, to level 5, which is full autonomy. And now these days we have them all on the road, some of them testing, and some of them we use it as a daily vehicles. AV technology responds to the expectation when the new AV technology will be introduced. Majority of participants, we've done that survey, 43% expected change. Expected change in the next 10 years. At the same time, another large choice of the 20% responded they don't know about it. So this is a clear indication that we need to educate and inform general public about the changes and benefits of that new technology of autonomous vehicle. To conclude, we have presented here a complex project of the intelligent transport system deployment. Novel ITS of the future will include various state-of-the-art technology, Internet of Things, and computer vision that will create big data. Big data requires data fusion and transmission channels with the high capacity. Edge and cloud computing will be responsible for data source processing. Artificial intelligence, AI, is already involved in real-time vision system and in the monitoring and management. I would like to acknowledge the support of the Saudi Arabian government for giving me the scholarship to study overseas in Australia. And also I would like to thank the former General Traffic Authority for helping us during the COVID pandemic to complete our survey back home in Saudi Arabia. And that's it. Any question? Thank you very much.
Thank you very much for the interesting talk, Mr. Abdulaziz.
Thank you.
So we are left with about 2 minutes time. We can have a quick question or two.
Okay.
So I would request the participants to kindly place their questions now. Well, if there are no questions at this point, I would be interested to know, Mr. Abdulaziz, that because there's a lot of computer-based technologies here. We are talking about deep learning, Internet of Things, and things, cloud computing, and things like that.
Yeah.
So we are talking about a day where manual intervention will be reduced to a minimum level, perhaps, right? So how do you ensure reliability of the system?
You mean of the system that we're gonna apply it?
Yeah.
Yeah. Actually, with the work with the real-time company, actually they've been applied many of these things, and they're trying to improve day by day by collecting the whole data. So we trying to minimize the cost and having a helping with the previous data to achieve the new one.
Okay, that's very interesting. So I would once again like to know from the audience whether there are any questions, because we are still left with a 1 minute time. So we would be glad to take up any more questions. So I think it appears that there are no more questions. Thank you once again for a very interesting talk and upcoming technologies for our future.
Thank you.
So with that, we come to the end of the first contributed paper in this session from Mr. Abdulaziz. So we'll move on to the next paper, paper number 79, from Mr. Hao Zhu from China. So Mr. Zhu is going to talk about comparative study on pyrolysis behavior of human produced from acid catalyzed conversion. So he's from Zhejiang University, China. I would request Mr. Hu to start the, Mr. Zhu to start the presentation. You can share your slides, and you will have a total time of 15 minutes, spanning between 10:45 to 11 a.m. Thailand local time. So kindly stick to your time, and I would appreciate if you can keep 2 minutes time towards the end to have questions. Over to Mr. Hao Zhu, please. Yeah, we are able to see your slide. Kindly use the presentation mode so that we can see it full screen.
Okay. Can you see my screen?
Yeah, I think this is nice. Yeah. Okay. Kindly go ahead.
Hello, everyone. It's an honor to share my report at this meeting. I'm Hao Xu from the State Key Laboratory of Clean Energy Utilization, College of Energy Engineering, Zhejiang University, Hangzhou, China. My topic is comparative study on pyrolysis behavior of liquid phase humans from biomass. China is rich in biomass resources, mainly stores, which is abundant and easy to collect. The direct burning or disposal of store and other biomass resources will bring environmental pollution and resource waste and other problems. And in September 2020, at the United Nations General Assembly, China announced to the world the goal of achieving a carbon peak by 2050 2030 and achieving carbon neutrality by 2060. The efficient utilization of biomass energy is a key factor to solve energy and environmental problems. By hydrolysis, the strong biomass rich in cellulose and hemicellulose can be converted into plant chemicals such as furfural 5-hydroxy-methylfurfural and levulinic acid. FF and HMF are obtained from monosaccharide produced by hydrolysis of hemicellulose and cellulose through further dehydration and certification. This is the physical and chemical information of HMF and FF. They are yellow crystals and liquids at room temperature. These plant chemicals can and their derivatives are widely used in synthetic rubber, synthetic plastic, and synthetic resins. The plentiful chemicals can be further derivatized into a variety of high-valued added chemicals, such as furfural alcohol, levulinic acid, cycloplankton, tetrahydrofuran, and etc. In addition, there are many current roles for preparing hydrocarbon fuels through plentiful compounds. These are two typical roles. One is the growth of carbon chain between plentiful compounds through aldehyde condensation to form oxygen-containing intermediates, and then through hydrodeoxygenation of carbon chain to prepare gasoline and diesel. Another typical route is to directly hydrodeoxygenation plentiful compounds of their derivatives to prepare short-chain alkane or higher alcohols. As can be seen from the hydrolysis path of lignocellulosic, lignin does not participate in hydrolysis reaction, but will be modified to a certain extent due to the existence of acid condensation during hydrolysis. In addition, the plentiful compounds generated from the hydrolysis react with each other and cross-link with lignin to form insoluble humins, which is the main byproduct of hydrolysis and accounts for 20 to 40% of the mass yield of dry base biomass. It is of great significance to study the physical and chemical properties and the pyrolysis behavior of solid byproduct humins to promote their high-value utilization. Therefore, 3 kinds of humins prepared from biomass raw materials were selected, namely coal stones representing stone-like biomass and eucalyptus and pinus silvestris representing hardwood and softwood. Firstly, the distribution of elements and the component of primitive biomass was analyzed, and then the products of hydrolysis were analyzed, and the physicochemical properties of humans were characterized. In the analysis of pyrolysis behavior of humans, the distribution activity energy model was firstly used for pyrolysis dynamic analysis, and the PYGC mass was used for pyrolysis products analysis. In order to further study the precipitation role of pyrolysis products, TG12 mass was used for the precipitation of pyrolysis product with temperature. The yields of humins of coastal eucalyptus and silvestris was 21.73%, 26.5%, and 32.41% respectively. It can be found that the yield of humus is directly related to the lignin content of the original biomass, and the higher the lignin content, the higher the yield of humus. The lignin content accounts for 65 to 80% of the total mass of humus. Through FTR and NMR characterization, it can be seen that structure of three cans of human samples is relatively similar in the overall distribution of functional groups compared with the humus generated by monosaccharides. This humus has a lower carbon-oxygen double bond content, and the carbon base is mainly from the ring-open reaction of furan rings of FF and HMl. The decrease of carbon-oxygen double bond function group content may also be caused by the further analyzation of FF and HM after alcohol condensation reaction with carbonyl side chain of lignin. And the TG-DTG curve shows that the maximum weight loss rate of 3 humus is in the range of 383 to 400 Celsius. Compared with the wood quality of ground wood, the 3 humus have higher stability in the low temperature range because the condensation behavior between furan compounds and the lignin increased to understand the thermal stability of the residue. Humus tends to occur carbonization reaction rather than devolatilization reaction in the pyrolysis process. So the characterization of coke of humus, it can be seen that the carbon content of coke reach more than 85%. And because of humus complex structure and higher child yield, the DAEM model for simulating the macrodynamic thermal cracking, the contribution of pyrolysis reaction, including volatile narrow peak on behalf of the precipitation, the degradation of pyro reaction, wide peak represent parallel condensation reaction requiring high activation energy. The parallel condensation reaction is dominant reaction in HCS pyrolysis, and the condensation and the cooking of human polymers are more likely to occur in the pyrolysis process. And the pyrolysis products of humus can be divided into 6 categories: phenols, furans, and cyclopentanol, aromatic hydrocarbons, benzene furans, alphates, and some other oxygen-containing compounds. The furans are worth paying attention to because furans mainly include furan, methylfuran, dimethylfuran, cyclopentanol, methyl cyclopentanol, and furfural. More complex compounds such as benzofuran, indene, naphthalene were also produced by pyrolysis of humus. These products are mainly formed by condensation of furan fragments with unsaturated hydrocarbons through DA-alder during pyrolysis. The lower temperature range can be further found by TG12 mass. The signal of eosinophils and the glycol appeared first, and the peak intensity of all products was between 350 to 450 Celsius, which was consistent with the TG data. The maximum TG range of humans were mainly formed by the dissociation and volatilization of phenolic products. Obvious precipitation signal of firm products was observed in HCS pyrolysis products.
Mr. Zhu, you are left with 1 minute time.
Oh, okay. This is the main conclusion of the study. Of this study, humans of 3 different biomass are complex polymers based on aromatic and frame rings. The basic structure of humin is formed by aromatic rings and frame rings connected with aliphatic carbon chain. These 3 humins are good thermal stability and high cocoa yield. In addition, the pyrolyzed product of humans contains rich in plentiful chemicals, which can be further refined into high value added chemical and high grade raw materials. And this is all of my sharing. Thank you for listening.
Thank you very much for your interesting talk. We have just enough time for taking one question from the audience, please. Well, if there are no questions from the audience, Mr. Zhu, can you just highlight once more about the applications of this technology?
Application?
Yes.
In this study, we studied the main byproduct of hydrolysis, which is called humins, and it takes 40% of the yields from the biomass. So we mainly studied the pyrolysis behavior, and its pyrolyzed products such as trans fibrose can further used to improve the utilization of the whole biomass.
Okay, thank you very much. So thank you once again for your interesting talk. It is time that we move on to the next presentation. So if you may kindly unshare your screen, because the next paper is comparative study on, the next paper, paper number 95, is titled A Fuzzy-Based Model for Performance Assessment of Safety Systems. It's a long title from Mr. Mohammad Ghulam Zakir. This is paper number 95, and we are going to play it from the YouTube. So within the next minute, I'm trying to share the screen and play the lecture for you.
Hello, sir. I can't hear any sound.
Oh. Is there any difficulty in hearing the sound?
Dr. Arnav, just
Yes.
once you are sharing, there's a small check button. There's like, share audio.
Oh, I see. Okay, maybe I have missed out on that. Share sound, is it? Yeah. Okay, I'm very sorry. Let me play it once again. Sorry for the inconvenience. Let me know if you are able to hear it this time.
I'm Santi Doctor presenting our paper,
Yes, sir,
a
can hear
fuzzy-based
it.
model of the safety assessment of AP1000 and BBR 1200 nuclear reactor for cold leg break lock.
I hope it is audible this time to the audience.
Yes.
Can I have a response?
Yes, yes.
Okay, okay. Thank you very much for pointing out, Professor.
Loss of coolant accident with turbine trip. Carbon neutral electricity generation from nuclear energy is essential for continuous and reliable electricity production as well as for climate change mitigation. Public perception is essential for sustainable future of nuclear energy. However, performance improvement of safety system of nuclear power plants is one of the major aspects for making nuclear energy more acceptable to public. It is noticed that many of the worst nuclear accidents had occurred due to combination of malfunction, like failure of safety system, natural disasters, safety violation, man-made failures, and action. Like, for example, TMI accident had occurred due to human performance and malfunction of safety system. But currently there is no work on performance analysis of safety system for combination of malfunctions for any reactor. So for our work, we have chosen 2 generation 3+ nuclear reactor and combination of cold leg break loca with turbine chip to evaluate and to compare the performance of passive and active safety system for both reactors and to ensure if they fulfill the requirement of final safety report and report or not. Objective of our work is to compare the performance of active and passive safety system for chosen reactor and to identifying the weak aspect of the safety system to enhance the safety design and to know how to evaluate the performance of safety system of both other reactor for innovation and advancement of the reactor design. So to enhance the nuclear energy sustainability, we choose the environmental sustainability as indicator. However, safety of nuclear power plants greatly affected by environmental sustainability. In this context, we have developed a global safety index for AP1000 and BBR 1200 nuclear reactor using only the performance of safety system. BBR 1200 is a pressurized water reactor designed by Russian State Nuclear Energy Corporation Rosatom, and the BBR 1200 is the upgrade version of BBR 1000 with new active and passive safety system. Washington Electric Company developed AP1000 reactor by enhancing the safety system of AP600 reactor. Sensing time, response time, recovery time, and core damage frequency were taken as input parameter for fuzzy interface system. Here, sensing time means when the scram signal is detected by the safety system. Response time is the time that takes for the safety system to react to an accident and begin mitigating its consequences. And recovery time is the amount of time it takes for the accident to appear to be over and the reactor to return its normal operating settings. And the probability of core to damage or meltdown is measured by CDF. So for first 3 input, we have taken from PC-Tune simulator by simulating 100% of 100 centimeters square cold break loca concurrent with turbine chip for both reactor, and the CDF were taken from design manuals for both reactor. The Mamdani type fuzzy interface system for 4 inputs and 1 output are shown in figure 2, and the relationship between output and input indicators for our work is expressed in equation 1. Table 2 shows the input and output fuzzification. Here, each indicator and the output were classified as high, meaning good in terms of CDF, and quick in terms of time, medium and low. Low means bad in terms of CDF and slow in terms of time. For example, if sensing and response and recovery time and CDF is low, GSI will be bad. In this way, we have developed 81 rules for determining if the GSI is bad, satisfactory, or good. For both piston simulators, malfunction were initiated at 5 seconds after the reactor operating at 100% power. But the safety system of AP1000 and VVR1200 reactor were activated at different time. And for analyzing the variation of the pressure of a steam generator and the flow of a reactor coolant pump, we have chosen only one steam generator and one pump among 4. For both reactors and in table 2, some parameters of VVR1200 and AP1000 before and after the malfunction are given. For example, when the pressure of a pressurizer started decreasing, the coolant in the RCS reactor coolant system started boiling, and the boil fraction also increased accordingly. But the pressure of steam generator and the flow of a pump increased over time. Concentration of a boron in the coolant increased to reduce the reactivity and also to mitigate the consequences of the malfunction. Figure 3 and figure 4 shows a variation of different thermal hydraulic parameters of VVR1200 and AP1000 reactor. For example, flow of hydroaccumulator, flow of a passive residual heat removal system, flow of steam generator, and level of a pressurizer. After about 51.5 seconds, both reactors started regaining its initial condition or steady state condition. Here is the summary of input with linguistic appraisal in the bracket and output that we have found for our work. And in figure 5, the effect of variation of sensing, response, recovery time, and CDF on global index system are shown. And in this 3D graphical view, we can find that with increasing value of sensing time, response time, and recovery time, the GSI value was found to be decreasing accordingly, whereas the global index safety index value was increasing with higher value of CDF. Finally, it is found that the VVR1200 outperforms AP1000 in terms of accident sensing and response time, but the recovery time for both reactors were found to be equal. And the safety system for both reactors were capable of restoring the safe operating condition of the plant without any involvement of the operators. Thus, the global safety index of both reactors were found to be satisfactory, and the plant can mitigate any consequences of a combination of design basis accident and anticipated operational occurrences, or any combination of them. Our result is in good agreement with the similar work previously done, where only LOCA was postulated accident. For future work, this work can be verified with other simulation tools like ReLab using same input parameter for authenticity. And this work can also be extended by combining the probability of accident occurrences and the consequences of accident on human and environment with the performance of safety systems to develop another safety index. Here are some important references I have used for our work. Thank you. Sir, you may ask question if you have any. Sorry, you are muted, sir. I can't hear you.
Yeah, I'm sorry. Yes. So, good morning, madam. You are available on behalf of the authors to answer some questions from the audience. Thank you for a very interesting presentation, and it's a very critical technology, I understand. So we would invite 1 or 2 questions from the audience regarding the presentation. Okay, so if there are no questions from the audience, I just wanted to know from you, madam, that do you incorporate some redundancy into the system? Because this is an extremely critical area where any accident could be extremely hazardous and could have long time consequences. So do you incorporate some redundancy to improve your reliability?
Sir, most nuclear reactor have redundancy in it because, for example, a nuclear reactor has like 4 safety system. Is like a simple pump maybe has 4 different types, so it has inherent redundancy in it. So I haven't considered it externally because it has inherent redundancy in it.
I see. Okay. So you have tried to look at the problem from a simulation perspective and try
Yes,
to
sir.
assess.
Yes, sir.
Okay, yeah. So it was a very interesting piece of work. Thank you once again. So we are running out of time allocated for this paper. So we'll move on to the next one. Paper number 33, scheduled between 11:15 to 11:30. Performance assessment of solar assisted anaerobic digester system, simulation and application in central Queensland region. This is a paper from Mr. Mahmudul Hassan from Central Queensland University, Australia. So I would invite the author to kindly present and begin by sharing the slides.
Hi, Prof. Can you hear me, please?
Hi. Yes, you are audible. So if you can kindly go to the presentation mode, then we'll be able to see your slides clearly.
Okay.
So if you could spare 1 or 2 minutes towards the end for questions, that will be highly appreciated.
Okay. So is it my presentation?
No, not yet in presentation mode. At least I cannot see it that way. I mean, slides are visible, but not in presentation mode.
Okay, got it.
You can perhaps try resharing it once more. In case it does not work, we'll go ahead with this format. Otherwise, you will lose time.
Okay.
To further improve the dining prediction.
Press F5. Press F5 from your computer.
Yes, usually that works. F5.
No, it's not.
It's all right. In that case, you can go ahead and start the presentation.
Okay. Okay. Sorry, Prof. I think something problem here because
it's all right. You don't need to worry. You can go ahead.
Oh, okay. Hi, this is MD Mahmudul Hassan from Central Queensland University. My topic from this paper is performance assessment of solar assisted anaerobic digester system and the simulation and the application in Central Queensland region. So the outline from this paper, it will be the introduction and objective of the study, the methods, result, and at the end, it will be the conclusion. And first, I go to our world demand for energy is increasing rapidly. So we are looking for the alternative, and the researchers, they are trying to find the alternative and renewable sources that is help to help the environment degradation and for the fossil fuel declination. And that from the title, it can be seen that the my topic from this paper is that biogas, where we can use the waste to energy. And this biogas as an energy source, which is now, and not now, it is for long term, it is increasing the popularity for the both small and large scale applications. And in this case, it is the temperature that help and it plays a key factor for the biogas production, where the temperature for the biological methanogenesis, it for extensive range of the temperature, that is start from the 20 degrees Celsius to 100 degrees Celsius. But there is still some challenges that to how to improve this temperature in the anaerobic digester system. So where the solar system can be helpful, that to maximize the temperature, especially in the central coastal area, that where the subtropical climate, the temperature varies so much. So this temperature can be used in the anaerobic digestion system and can increase the maximization of the biogas production. And it is also to help the value the carbon nitrogen ratio for the good fermentation and the favorable temperature. So the objective of my study here, that the solar assisted biodigester system, where I use the Transit software to see the viability and to check that how it can be used in this region or not. And from that system, we can find out that the heating methods that the solar system, the feasibility of the anaerobic digester system, as well as with the subtropical climate. So here from the methods, is the Transit software is being used, and the total modeling and the system modeling has been produced from this system, and the outcome was a fruitful outcome, that is where we can achieve from the simulation, that is the environment temperature, the digester temperature, the radiation, and the total biogas production. How much we can assume that how much biogas production can be produced from this system, and we can modify that the required temperature and the required place, whatever we need, we can put it here, and we can get the estimation that how much biogas we can produce. And here we can see that from the result that the region that is it is, as an example, if we take from the Rockhampton region, the maximum temperature it is varies, and as well as the solar radiation from the two typical season, because we know that the temperature varies from the one to low. So some of them from the summertime and some of them from the winter time. And the figure shows that the summertime, it is obviously it is the maximum temperature, and the and as well as the solar radiation also the high. So from the simulation, we can get that the average temperature when we run in the simulation that we got is the highest one, the 43 degrees Celsius, and as well as in the system it is the 41 degrees Celsius. And for and it is the I mean good outcome from the simulation that we I can achieve from the Transit software. And from the upper figure and from the lower figure, it is also the comparison between the two different seasons. The first one is the summer season, where we can see that the the optimum temperature can be achieved, that is the 35 degrees Celsius, and the biogas production is also getting from the summertime. And on the winter time, we can see that some temperature we can achieve, and as well as the biogas production also have the good result. And this and all it is connected with the temperature. And this is in this paper, just we try to check that the feasibility test in the system, that how the biogas production using the solar assisted system can be worked. And from the below figure, we can see that the average the whole year temperature, that the during the summertime, during the autumn, winter, and springtime, that how much the biogas production can be achieved, and the reactor temperature also in the under the certain condition, and how it works. And yeah, so from this simulation, we can see that this solar system that which satisfy the metabolic temperature of the anaerobic digestion, and in indication of the solar system can significantly contribute to the biogas production in winter, which is comparable with the summer as well. And therefore, solar energy is a highly desirable alternative for the biogas plants in subtropical climates. So that's all from my side. Yeah, thank you.
Thank you very much for the interesting talk. So we have quite a few minutes left for questions from the audience. If there are no questions from the audience, I just had a question or two for you,
Yes,
Mr. Hassan. So what I understand is that you could do a numerical simulation
yes.
to study the performance for the solar assisted anaerobic digester system. So what kind of uncertainties may be there in the numerical simulations, do you think? Or what kind of modeling assumptions, approximations that you have made?
I mean, the uncertainty, Prof, there is something we need to consider, like outcome of the we need to set the optimum value, like the variation where it is we can run this simulation with this model will help to estimate the idea that like suppose here I'm in Rockhampton, Queensland, that how much biogas can be produced from this area if I put this Rockhampton region. But some cases it is very difficult to get the input data, give the input data. So you need to redraw the modeling, and you need to give the input as well. And on the other hand, we need to give the input of the waste. I mean, when we put some waste inside the digester, that one is another challenge to get that parameter, certain parameters. So yeah, this is the thing, the problem. Yeah.
Yeah, that always happens in numerical modeling. We do have approximations. So are you also planning to set up a pilot plant to test?
Yes, doctor, this is here, just I try to check that the feasibility study, that how it works. And now I have set up as well. I'm going to set up, so then I will compare this modeling with my real data, so that how it works. And that is the next step, to compare this simulation data with the real experimental data.
Yes, of course. So that's the logical extension. Yeah.
Yes.
So thank you once again for your very interesting talk. So though we still have about 1 or 2 minutes left, I would once again go back to the audience and ask whether there are any questions before we move on to the next paper. it appears there are no more. So thank you. And we move on to the next paper.
Thank you, Prof.
Yeah, sure. And we move on to the last paper of this session, effectively, which is scheduled during 11:30 to 11:45. It is paper number 119. A review on performance and emission of diesel engine fuel with ternary blends of diesel, biodiesel, and bioethanol fuels from Mr. Mahdi IZ, Central Queensland University, Australia. So it's the same university from which we heard the last paper. So,
hello, can you hear me?
Yes, you are audible. You can kindly share your slides.
Of course I can.
And
Yes.
go ahead with the presentation. So please leave 1 or 2 minutes or little more towards the end of your presentation for questions. Please leave that time.
Yeah, just bear with me to share the screen with you guys.
Sure.
Just bear with me. Sorry, I have problem here. Just bear with me, please.
So you are not able to share your screen?
I think my file is not opening properly, so just bear with me. I don't know what happened, to be honest.
Okay. You need not be anxious. Try it out.
Okay. So can you see the screen?
Yes, it is visible. It's nicely visible. Yeah.
Yes,
Please.
sorry, I do apologize for the delay. So this is Mehdi. This presentation is a review on performance and emission characteristics of diesel engine fuel with ternary blends of diesel, biodiesel, and bioethanol fuels. Obviously, I'm from Central Queensland University, Australia, and this is the actually presentation I have for today. The reason I selected this topic to present at this stage, because we know the production and utilization of environmentally sustainable fuels instead of conventional fossil fuels in varieties of application have recently attracted researchers' attention. And the significance, and because we know that we have like the fossil fuel emissions and depletion of fossil fuels such as oil, natural gas, and coal are the main source of the current global energy, and they account for about 88% of the global energy supply. And because of the depletion of these fossil fuels and global pollution due to the extensive use of fossil fuels, researchers are focusing on alternative fuels which are more compatible with environmental and produce less emissions. Bioethanol and biodiesel are two of these alternative fuels, and biodiesel, though, because of its similar characteristics with diesel fuel, can be easily used in diesel engines instead of diesel fuel, but considering previous studies, adding more than 20% of bioethanol to the diesel fuel might cause diesel engine malfunction. So biofuel advantages such as reproducibility, renewability, high oxygen content, and less emission is one of the other reasons I actually I have done this review on the previous papers. As we know, bioethanol has higher latent heat of vaporization compared with pure diesel fuel. And as a result, temperature of the end of the combustion process in diesel engine can be decreased by adding ethanol to diesel fuel, which could reduce NOx emissions. And also lower carbon hydrogen ratio and higher oxygen content of ethanol diesel fuel mixture can improve complete combustion in diesel engine, which causes a reduction in smoke, unburned hydrocarbon and CO emissions. Diesel engine are one of the major contributors of air pollution in the world. And unburned hydrocarbon and nitrogen oxide emissions lead to ozone formation at the ground level. So the other reason is commercialization of the biofuels. There are some reasons which prevent commercialization of biofuels. For instance, biofuels have weaker combustion characteristics compared with fossil fuels, and engines may need modification in their design to be able to use biofuels as common fuels. One of the methods for commercialization of biofuels is adding small proportion of them to fossil fuels, therefore finding the optimum biofuels and fossil fuels blends, considering all criteria, including emissions, amount, and engine performance is crucial.
Excuse me, your slide is fixed in the page 2. It's not next to the slideshow.
Sorry?
Sorry, yes, your presentation is standby in the page 2 only.
Because I'm explaining the page 2 actually.
Oh, okay,
I'm explaining
yes.
the page 2.
Oh,
and
okay.
The last one in page 2 is 5. Actually, I'm just explaining the items I have here. The limited study. Another reason of this study is limited study on diesel engine investigation and modeling using bioethanol combination with diesel fuel. So as we know, based on my study, a very limited number of studies were reported to investigate diesel engine performance fuel with ternary fuel blends. Also, only a few projects have considered modeling of diesel engine performance fuel with ternary fuel blends. Because as we know, model can predict engine performance for a wide range of fuel blends, which helps designer, manufacturer, and decision maker to analyze behavior of different fuel blends on diesel engine performance and to find, and it helps to find optimum biofuel fossil fuel blends. By reviewing the previous investigation, I just categorized the previous investigation in 4 categories. One of them is diesel engine fueled with bioethanol diesel fuel blends. Bioethanol is an alternative, fuel which can be derived from the fermentation of feedstocks. Adding bioethanol to diesel fuel blends is beneficial for some of the engine features such as power and efficiency, but because of the different characteristics of diesel fuel and bioethanol, using bioethanol in high proportion in diesel engine is not feasible. Also, the other category is biodiesel as a co-solvent for bioethanol diesel fuel blends. So as I mentioned before, because we can't actually use more than 15-20% of 20% of bioethanol in the diesel blends, biodiesel can be directly, and biodiesel has a very similar characteristic with diesel engine and also can be used as a co-solvent to the bioethanol and diesel engine, diesel fuel, and so many of the researchers can have research on this item. The other one is diesel engine fueled with bioethanol, biodiesel, and diesel fuel blends, which is a ternary fuel blends. So there are investigation of diesel engine using ternary fuel blends, but they have some gaps. For instance, they haven't investigated effect of adding different proportion of bioethanol into diesel engine. Likewise, there is no prediction of possible changes on engine performance by adding higher or lower proportion of bioethanol to diesel fuel. These gaps can be covered by developing a simulation model to predict performance changes using different fuel blends. So, and the last category of the investigation was computational investigation of diesel engine fuel with different fuel blends. So, as I mentioned, creating a computational model of a diesel engine using computational fluid dynamic software may be the best possible solution to minimize numerous experiments and identify optimum operating condition for maximum output. More data will be generated by modeling of the blends, which cannot be experimentally measured. And model also predicts the results for engine performance for other fuel blends. So this is the simulation approach for combustion model generation. As we can see, the design combustion model and define boundary conditions. And then we create mesh for combustion chamber model, define model engine characteristic based on test engine, and then input fuel properties into the model for simulation, and then trial simulation running to check model works or refine it again. And then the data will, or maybe the exported data from the model can be validated with the experimental data. And then we can optimize the model for higher engine performance and lower emission. So some of the questions which arise from the previous research works are, what are the optimum ternary fuel blends which increase engine performance, torque, power, brake, thermal efficiency, and specific fuel consumption, and decrease engine emissions at the same time, considering experimental and model results? And why do these blends show this behavior? What are the challenges of optimizing engine performance and emission for ternary fuel blends? And which parameters engine speed fuel blends have the main effect on engine exhaust emission? So by synthesis, the previous research works, and we can conclude that very small share of biofuels in Australian renewable energy we have. So as we can see, only about 1% of the Australian renewable energy allocates to biodiesels, and that's why actually I'm reviewing the previous paper and see the gaps and how can we improve and increase actually this share in the Australian market. Secondly, more research work is needed to find the optimum and reliable biofuels blends to replace conventional fuel and decrease pollutions. And also we can cover the gaps on the previous research works in this regard. So I can just to complete the actually the second section on this part. Actually, more research works are required to find the optimum and reliable biofuel blends to replace conventional fossil fuels. For some reasons, such as high price of biofuels and their big combustion characteristic, customer and manufacturer are yet to get used to them. But we can, with optimum fuel blends, can enhance actually in engine combustion features and decrease engine pollutions. And we can work on that to cover the previous research gaps by using the models, and then actually go to find the better optimum biofuel blends in this regard. Previous research will show the benefits of using biofuels, but there are some gaps, as I mentioned, and we can cover these gaps with using we can cover these gaps with some of the other research works. So yeah, I have like other sections, but I think my time is going to go finish in 1 or 2 minutes. So I'm happy to answer the question. Thanks for your attention.
Thank you very much, Mr. Razi. So we'll invite 1 or 2 questions from the audience, please. If there are no questions, you were just showing a schematic diagram of an experimental facility. So I assume that it's connected with the topic that you talked on. So
which one?
You just showed a schematic diagram of an experimental setup. So is it a part of this?
Yes. Actually,
yeah.
Because majority of the investigation or maybe research works I have reviewed are working on a diesel engine. I have just shown this one to show what's the experimental setup for that previous experiment. So they have done all, because my research is only like investigating the previous research works on diesel engine, and I have reviewed all the papers which they have performed on diesel engine using the different fuel blends. That's why I'm just showing. I have put this diagram here to show what they have done. Like the majority of the previous research works have done the research on diesel engine using different fuel blends. That's all.
Okay, thank you very much once again for the interesting talk. So if there are no more questions from the audience, we'll close this session number 9 here. I thank all the presenters for their very interesting presentations and for reporting their research work, and also thank the audience for patient hearing and staying with us. So I hope that you find the remaining sessions of ICEP 2021 very useful, and wishing you all the best. I think we can close this session.
Thank you.
Thank you. So, Dr. Nathawat,
Yes.
I think we can formally close this session 9 now, and attendees can move on to the subsequent sessions to listen to those presentations after the tea break.
Yes, okay, thank you. Yeah.
Okay, sure. Thank you very much for being with me and assisting me.
Yeah.
Thank you, participants, once again.
Yes, thank you very much.
Wish you all the best.
Thank you so much.
Have a nice day. Thank you very much.